Okay, so in the final segment, I want to add IO so that we can look at our particles. And to do that, I'm going to use the same function that I used to get it to the screen, the output, except I'm going to direct it to a file. It's almost the same function. So let me find, here we go. So I'm going to add this write file function. So this write file is going to take, this is always a little confusing about C, but you're never quite sure the intent when you see a pointer. But in this context, some people like to even do that to emphasize it's going to be an array of pointers. I'm sorry, an array of points, but this is equivalent. It doesn't matter. I'll just do that. And the end-to-end says, well, I want n instances of a point starting at this address. Okay, so they're both correct, but some people prefer one or the other. Okay, so to do that, I have to create a file object. So there's this opaque type, capital FILE, which is an stdio.h. And I just say fopen, it returns a pointer to this opaque type. I don't need to know what's in it. I just know that I have the handle. And I give it a file name, and I say I want to write. I don't want to append, so it'll clobber it if it's there. And then I do the same print statement. I'm just printing the coordinates of the point. I'm not going to print the distance anymore because I don't need that for plotting. Then I have to close the file. Okay, so that's simple IO. Not a lot to say about it. I just wanted to show it to you. And I have, after qsort, I write the file. The last thing I do is I call free. So there's a hash table of pointers that have been in the memory allocated associated with them that are kept by the runtime. So as long as I don't go out of scope with a malloc statement, in other words, P doesn't go out of scope in this case, then I won't leak. Problem is, it's pretty easy for P to go out of scope. Like if I malloc P inside a function and then I return from the function and I have no way to I didn't return the variable P, it's going to be gone, but the memory is still going to be associated with it. So I need the handle. As long as I have the handle, when I call free, the system knows how many bytes were malloced with the call that created the pointer P, or the call that was associated with the pointer P. So it's, in a sense, it's not that bad. I just say free, but you got to make sure it's in scope. And unfortunately, people have things go out of scope all the time, oftentimes in loops, and memory grows wildly. So there's a lot to say about that, but right now, just start freeing your memory early before, don't have it be an afterthought, because it just, our codes will become complex before you've developed a good habit, and it will be hard to sort of ever do it correctly. Okay, so I say qsort, then I say write, and then I've got the file. So we'll just run this version 4, and let's just say I'll do 100 particles, something impressive. I guess I have to compile it first. I'm sure I'll get at least one. Maybe I'll get a second complaint. No, still just that same one. So I'll say .v5 100, boom. And then I will say, I'll just look at the file in Unix. I think I called it data.txt. All right, I didn't line it up beautifully, but whatever. So I just have 3 columns of numbers. It doesn't have to look pretty, but I can use the formatting statement if I want to line it up by doing the field width. Okay, so now what I want to do is I want to plot it with GNUplot. GNUplot is a nice Unix-based command line plotting tool. It's not, I mean, I prefer MATLAB. A lot of people prefer using MATLAB type capabilities in Python. Whatever you use, I think for the kind of things we want to do in this class, GNUplot is very convenient because it's tightly integrated with Unix and with C. So I can just create a simple plot script like this plot script right here. So X label, I'll say X position. I forgot to change this from last time I did it, Y position. I'll say particle positions. All right, so I just have this simple the GNUplot script. And what I'm basically saying is plot the data. It will recognize that 3-column format because that's what splot looks for. And I say I want it to be dots. So I just want to do a scatter plot. I wouldn't worry about that too much. So I get into GNUplot and I can just say load data. I think I call it data.txt. like something about that. That's weird. Let me just take a quick look at it. Oops. Getting sleepy. I want to load not the data. I'm loading the script, which plots the data. So load plot.scr. Better luck with that. Okay, boom. And there is a plot of the 100 particles. You can sort of spin it around, see them in space. And you could call GNU plot directly from C. Maybe I'll show you how to do that. But you know, I wanted to at least show you some input, some output, and calling some C libraries and manipulating some of the basic constructs that I went over in the notes. So I will post this example on Dropbox. And this is really just a chance to get you warmed up. And the next set of lectures, I really want to go into the development of abstract types, interface design, and deeper into how we do memory allocation when we build user interfaces, or not user interfaces, but when we build libraries that we expect third parties to use, for example, data structures or math libraries or anything else. So we'll talk about that next time. But for now, hopefully that gets you started and gets you asking some questions and maybe augments some of the details that I showed you in the notes.